and welcome to the Math League YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Shown below are two congruent isosceles right triangles. A square is inscribed in each triangle. What is the ratio of the area of the smallest square to the area of the larger square? Express your answer as a common fraction. Since we're not given any numerical side lengths, we're going to prove this generally. Let's say the legs of this isosceles right triangle has a length of s. Then we can see I drew these legs all have length s, and therefore its hypotenuse will have length s times the square root of 2. Let's let A be the side length of the first square, and let B be the side length of the second square shown on these two diagrams. Then if we investigate the first isosceles right triangle with the entire square of side length A, we see that this square splits this bigger isosceles right triangle into the square and two smaller right triangles. We realize that these right triangles are also isosceles because they have the same base angles of 45 degrees. So since we know that one of the legs is A, shared by this side length of the square, this length is also A, and this length is also A. That means S equals 2A, and A equals S over 2. We'll save this value for later. Let's consider the second diagram with the square of side length B. We see that we split this isosceles right triangle into 4 parts: the square and 3 isosceles right triangles. In this case, we'll consider this isosceles right triangle and this isosceles right triangle. We see that these two isosceles triangles are also, they're isosceles because their base angles are 45 degrees. And since one of the legs shares a side with its square of side length B, this length has length B, and this length has length B as well. And so 3B equals S root 2, B equals S times the square root of 2 over 3. Now we have the side lengths in terms of S. And so we need to see which one is smaller and which one's bigger. If we test these values into a calculator, 1/2 is 0.5, and root 2 over 3 is around 0.47 or so. And so the second square will be the smallest. And so the ratio of the side length of those two squares, the smaller to the larger, is root 2 over 3 over 1/2. That's 2 root 2 over 3. So that's the side length B over A. And to find the ratio of its areas, we simply square it because areas are a squared quantity. And so 2 root 2 squared is 8, 3 squared is 9. So the ratio is 8 over 9, and we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.